applications of logarithms. I've told you guys as we were getting closer and closer to this, the more excited I've gotten, just because you can see math outside my room in places that you know about but have never thought about before. Okay? The Richter energy number. Do you have any idea what that is?
No.
The Richter scale? Anybody ever heard of the Richter scale before? It's the earthquakes, right? So you've heard about earthquakes before, right? Have you ever been in an earthquake?
Yes.
Anyone? Yes? Excellent. Okay. Guys, the Richter scale is a logarithmic scale. Okay? If you'll turn and look at the back real quick, the very back, I printed this off from the National Earthquake Information Center. It's just, here's the magnitude, this is the intensity, and then here's a description about this particular magnitude. From 1 to 3, you don't really feel it. Hardly ever. Okay? From a 3 to 3.9, usually it's only going to be, if first of all, if it's an intensity of 2, so probably if it's a lower end, you're only going to feel it by a few people at rest, laying in a bed, or sitting in a chair on the upper floors of a building. Okay? If it's a higher intensity, like an intensity 3, sometimes you might feel it, but especially if you're on upper floors of a building. Why is it going to be felt by people on upper floors of the building?
The top will shake more than
the top will shake more than bottom, right? Okay, the flexibility thing. Many people do not recognize it as an earthquake. They might think a big truck passes by or something. Okay? And they have to guess at how long those last. It's really hard to tell. Okay? But starting at 4s, you're going to feel it indoors, outdoors by some during the day, because you can see stuff move. All right? At night, some people might be woken up, however you want to say that. Things on the walls might be disturbed. The walls might make a cracking sound. If it's standing motor cars rocked noticeably. What does that mean? You can see your car move, right? If it's sitting in the driveway or something, okay? A higher intensity 4, everybody feels it, and most are awakened. Things are broken. Unstable objects can be overturned. Like if this cup sitting back here, it's probably going to get knocked over. Okay? So hopefully you've drank all you were supposed to. Your cups are empty. 5s. We have 2 different intensities, 6 and 7. Okay? Felt by all. A 6 is felt by all, and many are frightened. Yes, sir?
On 5, why would a pendulum clock stop?
That's a good question. Okay? On 5, why would a pendulum clock stop? Oh, did I miss that? On 4? Yeah, on a 4, but intensity 5. What makes a pendulum clock swing? Gravity, right? Just keeps on going back and forth. But if the stability of the ground that it's sitting on, or the earth, or the house, or whatever, if that's moved a little bit, then it's going to swing out of like its normal swing, and it's going to get off, and it'll probably end up stopping. Okay? Good question. Good question. Okay? So everybody feels it. Fallen plaster. What's plaster? Stuff on the wall, stuff on the ceiling. Okay? Higher intensity 5 is going to be, you're not going to see anything, hardly anything in good design buildings, but as the design gets worse and worse, what? It gets worse, doesn't it? Okay? 6 to 6.9, two different intensities here, right? 8 and 9. First of all, everybody's feeling it, right? Starting at 5s, everybody's feeling it. Even specially designed structures, there's going to be a little bit of damage. Chimneys will probably fall over. Factory stacks will fall over. Heavy furniture even could be overturned. The earth is moving so violently that it might even flip your couch over. Okay? Higher intensity, the 9, damages considerable in specifically designed structures. There are structures specifically designed to withstand earthquakes. Okay? And even in those buildings, there's going to be some damage. Okay? Great damage in substantial buildings. What does that mean? A lot of damage. Substantial buildings. What does that mean? Like big ones, right? Okay? And then buildings may be shifted off their foundations. If it gets to 7 or higher, yee. Some well-built wooden structures will be destroyed. Most masonry and frame structures are destroyed with their foundations, and rails are going to be bent. What rails?
Railroads.
Railroads. Okay, railroad tracks. Few, if any, structures are going to remain standing, and bridges will be destroyed, and the rails will be greatly bent. Do you notice that it's increasing, like in intensity right here? It's only listed as a 10, but if it increases because it can say or higher. And the damage will be total. Lines of sight and levels are distorted. Any idea what that means? So like right now I can see from, let's pretend I can see from here to the field house.
Okay.
Right? I can see from here to the field house. If my line of sight is destroyed, it means some of the earth has been pushed up so much that I can't see the field house anymore. Like, because there's earth in my way.
That'd be scary.
Yeah. Okay? So, what I'm going to show you guys now, I don't exactly know how this is going to work for the video. We'll just be brave and try stuff, okay? How about that? There is a website called the USGS, the United States Geological Society, or something of that sort, okay? Actually, Aaron, would you grab me an iPad real quick? That would probably be easier. And at the USGS, you can actually go and look and see all the earthquakes that have happened around the world that are a 2.5 or greater. Why would we care only about 2.5s or greater?
Because that's when they start being able to be felt.
Yeah. Probably around 3 or higher is when we can feel them, right? But it's not going to do us any good. Although it's pretty interesting to see all the earthquakes. Okay? Sorry, I'm just trying to find this real quick. Okay, so here's the USGS. I don't know if you can see that very well, but let's go here to earthquakes. Okay, here's just all the list. You can actually look in the list, but here is, hopefully you can tell that's the United States, right?
Mm-hmm.
So all the orange dots have happened in the last week. They usually have a code on here, but I don't see one, so they must all have happened in the last week. See, I'm just moving the earth around, not the actual earth, but just the earth on the iPad. Because that would be weird if I could move the actual earth around.
Yeah.
Kind of freaky, actually. Okay, so look what's going on right here. Papua New Guinea, right above Australia. See, there was some pretty big earthquakes, right? One was a 5.1, one was a 4.8, one was a 4.8. Okay, there's 3 there. If I scoot over here, let's look at South America. Oh, look at Hawaii. Why is there earthquakes in Hawaii? Because there's volcanoes, right? Okay, so let's go look at South America.
Oh, wow.
Mm-hmm.
The biggest one up there.
Quite a few, right?
Yeah.
Looks like the biggest one is a 5.3, right in the place where you can't see.
Oh.
Sorry.
I was like, what?
Okay.
Right.
But this is what I find interesting. Okay. Let me get back to the United States. That's Oklahoma. There's earthquakes in Oklahoma. What the heck are they doing in Oklahoma?
They're on a road trip?
The earthquakes are on a road trip?
Yep.
Okay. But look, there's also one up here.
Montana.
Yeah. It's like, there's Montana right there, so that's, what's it,
Wyoming?
Utah?
Wait, which one?
Nope, Wyoming, you're right. Sorry, my bad.
It
Look.
says on the one side.
Look at California. There's quite a few in California, isn't there? Okay.
Yeah.
So, why am I showing you this? Because it's cool? Well, clearly, it's cool. Okay, but what else? It's the logarithmic scale. Alright, so let's look at the math for just a second before we go on to some other stuff. The Richter energy number of an earthquake is the base 10 log of the amplitude. That's an equation. Can you tell that? The Richter energy number is the base 10 log of the amplitude. The Seattle quake of April 29th, 1965 measured a 7 on the Richter scale. The San Francisco quake of 1906 measured about 8.25 on the Richter scale. To those who know little about logarithms, 8.25 does not sound much more severe than 7. Using what you know about logarithms, however, tell how many times more severe the San Francisco quake was than the Seattle one. Well, the Richter energy number for, let's do San Francisco first. San Fran. Okay? Its Richter energy number was what? 8.25? 8.25 was the Richter energy number of the base 10 log of the amplitude. Okay? So how do I solve for A? How do I solve for the amplitude? If I put it in exponential form, I get 10 to the 8.25 power equals A. Okay? Now, if I put 10.25 into my calculator, 10 raised to the 8.25 power, it's that.
That's a lot.
E8 means times 10 to the 8. So we're going to just kind of let 10 to the 8.25 stand for itself for a second, okay? Seattle was a 7, right? So I rewrite that in exponential form, and I get 10 to the 7th power equals A. So how do I find out how many times more severe one is than the other? Divide. Okay? So let's divide San Francisco by Seattle. So we're going to say 10 to the 8.25 divided by 10 to the 7th. So I already have 10 to the 8.25 in there, so I can just say divided by 10 raised to the 7th power. 17 times, it's closer to 18 times greater, isn't it?
17.7828.
Okay? So basically 18 times greater. What does that mean? It was 18 times as worse. A stupid example that's not true, but to kind of help you get this into perspective, if in Seattle one house fell down, how many fell down in San Francisco? 18.
That's a lot.
Yeah, that's a lot. Okay? So that's one place that logarithms are used. Okay? Somebody read number 2, please. Actually, you can't because I'm making a video. The loudness of sound is measured in decibels. The number of decibels is 10 times the base 10 log of the relative acoustical power of the sound waves. Did you hear the equation? The number of decibels is 10 times the base 10 log of the relative acoustical power. Is it okay if I put rap? You do not have to worry. I will not be rapping.
Oh, come on.
No, for real, I will not. Okay? Trying to find a picture for you real quick, and I'm
So
not going
rap
to be
is
able to do
just
it.
one variable, correct?
Rap is just one variable. Yeah, we're just using that to represent that one thing. Okay? There it is. Okay. So the threshold of audibility, the relative acoustical power is 1. Well, if we're just trying to find the decibel, we're just putting 1 in for REP, aren't we? So I have 10 log of 1. That has 0 decibels. Okay? Soft recorded music is 4,000. So I have 10 log of 4,000. That's, what, 36? Because we're rounding to the nearest decibel here. Okay, so 36, is that good?
Yeah.
All right, so what about loud recorded music? 10 log of, how do we want to put this in? 6.8 times 10 to the 8th. Can we do that? Sure can. What?
10 to the x.
I can. Yes, we can have 10 to the x, yeah. 88. A jet aircraft. Whoa. 10 log of 2.3 times 10 to the 12. That's 124. Yeah, 124, correct?
The next one's 130.
The next one's 130. You did it already? Okay. 130. Threshold of pain. All right? You guys know I like to watch football, right?
Yes.
I was watching a football game, Seattle versus somebody. It didn't matter because they lost, right? Seattle won. But you know the big deal this year was how loud Seattle was. We're loud. We're the loudest stadium, right? Somebody, they had a decibel meter up on the
Mrs.
screen.
Kingston?
Yes.
Can you send Justin Betts to the office, please?
Can he come in just a moment, please?
Yes.
Okay, thank you. This was a screenshot I took of my television. 108 decibels.
Dang.
Where does that fall?
In between laboratory music and jet aircraft.
Yeah, almost as loud as a jet aircraft. You think they're really loud?
Yeah.
Yes. Heck yes. Okay? Now, the other thing I think you're probably most familiar with is number 3. The strength of an acid solution is measured by its pH. Have you done pH in chemistry? Okay. So neutral water. Oh, the pH is the negative of the common log of the hydrogen ion concentration. Okay? But did you hear the equation there? The pH is,
Did you stop the reading?
the pH is the negative, what does this mean? Common logarithm. It's log base 10, isn't it? Okay? Of the hydrogen ion concentration. So, Hick? We don't know any Hicks in Clyde. Nah. But you know what that stands for, yes? Hydrogen ion concentration? Okay? So, if we're just trying to find the pH, once again, are we plugging this value into here? We're just saying, in the calculator, we're just saying negative log, can't see that, negative log of 1, whoa, not that, go away, not you, 1 times 10 to the negative 7th? Oh look, me too, I got 7 as well. So somebody do this one, somebody do this one, somebody do this one.
I already got D.
So neutral water has a pH of 7. Where is that in the scale? Do you remember? It's right in the middle, isn't it? Okay. What about human blood? Exactly 7? Oh, so we need to do 7.2, at least 7.2, so we know it's not exactly in the middle anymore, is it? Okay. What about hydrochloric acid?
1.2.
Just 2? Did you expect that to be really low?
Yeah.
Hopefully, because it's called acid, right? And the really low numbers are the acids, and the really high numbers are the bases.
I got 1.6 on that.
Not 1.2, but I don't know.
That's okay. We'll say 1.6. 1.6 is fine. Is it really 1.6 or is it 1.7?
1.602.
So 1.6 is good, okay? Grandma's lye soap suds. Where do you expect this?
Up there.
It should be pretty high. It should be pretty base. Pretty base-ish? I don't know. What'd you get? Basic. Thank you.
I got 11.06.
1.03. How high does the scale go? Like, I'm truly asking. I don't remember if it's 12 or 13 or something, 14, something like that. You think it's 12? Okay. So that may be something we want to ask Mr. Fuquay today when we get to class. Then we can report back tomorrow. Okay? All right. There's a ridiculous amount of questions here. It does go to 14? Okay. All right. So there's a ridiculous amount of questions here, so I want to make sure you know which ones we're doing. Okay? You're going to do 5 and 7 and 10. you are going to do a couple more Richter scale problems. You're going to do number 2. And you are going to do number 1. How about that? I also want you to do number 5. But please keep in mind that number 5 is extra, because it does take some extra time. It says choose 2 other magnitudes that are a ratio of 2 and repeat the exercise in number 4, which means you've had to do number 4. Okay? Any questions about that? Okay. That's what you're going to do. Please keep in mind that you do have a test tomorrow. We will have a study session after school today and one before school tomorrow. I will be back in time for the study session today, even if I have to sneak out of my meeting. Although it's not professional, so I won't sneak. I'll tell them beforehand. Okay?
Okay.
Any other questions about how to do this? Now, guys, for the record, these ones on the back, these are about compound interest. Okay? Like banking. Banks use, stuff like that. The formulas that you need are these formulas up here at the top. Okay? So make sure you're looking. If this says compounded continuously, know that you're using the compounded continuously formula. Okay? Any questions about that? Any more questions from anybody? All right, Kingston out.